Let's go ahead and solve these problems one by one. So first one we have is this one, and we have to find the derivative of this one. So how do we find the derivative of this one? We simply go, and since it's a chain rule, you see, u to the power of something, okay, so u to the power of 100, so you can simply take the derivative of the function as it is, like I explained in my in various videos, so which I made on chain rule. So you simply bring the 100 down and subtract 1 from it, just like this, and now you just have to multiply by the inside function, right? The derivative of the inside function, and the derivative of inside function is simply 3x squared, and if you want to write it simplified form, so that should be like this. Okay, so now let's move on and do question number 2. So for question number 2, this one for question number 2, and you can see you have exponents and stuff like that. Okay, so this to the 4th cube. Okay, so you basically have a fraction, so with an square root. So for this one, you basically have to know, when you have like a 4th square root, this is basically equals to, like, for example, x to the power of 4th, x to the 4th square root, so that is basically equals to 1 over 4. Okay, just like if you have square root, so that is equals to x to the power of half, so this is basically equals to x to the power of 1 over 4. So because it is at the bottom, okay, so if it's at the bottom, so for example, if you have something like this, so these okay, so these are basically equivalent, x to the power of negative a half, because square root of x is basically x to the power of half, but if you put a negative, that means it's a 1 over x to the power of half. Okay, so here this expression that you see right over here, this is basically gonna be equivalent to writing x to the power of 2 negative 1 to the power of negative 1 over 4. Okay, so that means, like, we have a square 4th cube, how do we say it, 4th root, and it's at the bottom. Okay, so now it's really simple to take the derivative of this one now. Okay, so this is basically just like how we did for the first question, and now we simply have to subtract 1 from it, so we get negative 1 over 4, and now take the derivative of the inside function, which is x squared minus 1, so simply it's gonna give you 2x. Okay, so if you want to write it basically simplified form, so you see this is basically gonna be, this is gonna cancel out. Okay, so you'll have 2 at the bottom, so if you want to write this simplified, so you will have x squared minus 1, and then you will have to the power of 5 over 4, and then you have a 2 in the denominator, and then you have a negative x at the top. Okay, so this is basically gonna be your answer if you want to write it simplified form. All right, so now let's move on here, and this, you guys can see, this is a chain rule again. Okay, we have an inside function of this one right over here. So how do we derive this one? So this is really simple. So what you do is just take the derivative of the outer function. Okay, so what's the derivative of sine of x, cosine of x? That's simply negative sine of x. Okay, so we're going to take simply the derivative of as it is. Okay, just the outer function as it is without touching anything, and afterwards what we're going to do is that we are going to take the derivative of the inside function. Okay, so times by the derivative of the inside function, and what the derivative of inside function says, that's just like x squared. Okay, so what's the derivative of x squared? Simply 2x, right? So it's just simply gonna be 2 theta. So that's it. So negative 2 theta sine theta squared, that's it. It's basically gonna be your final answer. Okay, so now let's move on. Have this one. See, these are different, because here you had the outer function in this one and you had inner function in this one, but now you have cosine squared of theta, which simply is equivalent to writing like this. Okay, so if you want, you can write it like this. They are basically equivalent. So now this is again a chain rule. So like I said, what we do, we bring the 2 down. Okay, we bring the 2 down and we take the simple derivative like this without taking the derivative of the inside function first. Okay, so simply do like this. Okay, and now we're going to multiply by the derivative of the inside function, so negative sine theta. Okay, so that is basically gonna be your final answer. So negative 2 cosine theta sine theta. All right, that's basically what you have to do. Now Let's move on to question number 5. One function, and then you have another function. So you are seeing one function multiplied with another function, and every time you have the case of one function multiplying with the another function, what do you use? Remember, you use product rule. Product rule, f prime times g plus g prime times f over g squared. That's nothing but simply the formula for product rule. Alright, where our f is basically gonna be equal to the first function multiplied. Okay, so that is e to the power of at, and our g is basically the second function. Okay, so then if we go ahead and take the derivative of the f prime, which is basically the function f, so what is the derivative of this one? Okay, so remember, like if you have the derivative of e to the 2x, how do you take the derivative of this one? So this is basically like e to the 2x, and then the derivative of the inside function, so that you have is e to the x. So what's the derivative of e to the 2? What's the derivative of 2x? So that's simply going to be 2. So if you take the derivative of e to the 2x, that is gonna be this one. Okay, so similarly we have simply the same thing over here. Okay, so here we have the derivative of e to the power of at. So a is treated as a constant. Okay, so and t is the variable. So if you go ahead and now take the derivative of at, that simply should be a. Okay, so now let's move on. So if you go ahead and take the derivative of negative of g, okay, so then sine, the derivative of sine, that's basically cosine of bt. Okay, so now this is your inside function right over here, bt. Now simply go ahead and multiply by the inside function. So the inside is bt, that's simply like cosine of 2t, so that should be like 2, right? So you have to multiply by the inside function, right? The derivative of the inside function, and t is a variable, so that is going to be 1, and so your bt is going to become b. Okay, the derivative of bt, because like for example like 2t, that became 2. So just put the g squared at the bottom. That was for quotient rule. The product rule is simply this, f prime times g plus g prime times f. Okay, sorry for that. Okay, so now we can simply go ahead and put in the formula. So a e a t times a g, okay, f prime times a g plus g prime times an f. Okay, so EAT. So that should be it. But if you guys want to write it in a simplified form, so we can basically go ahead and factor e to the 80, because both expressions have this. So b cosine bt. So if you go ahead and write this like simplified form, so this should be your final answer. I didn't take the derivative of this one, so if we take the derivative of this one, so you guys can see this is basically a chain rule. Okay, because you have this outer function and this is the inside function, just like e to the power 2x we had, right? So this is basically the same thing, right? If we go ahead and do this, so we have to multiply by the inside function, okay, which is 2. So just like that, you're going to take the derivative of this as it is and then multiply by the inside function. So if we go ahead and take, so we'll have the same thing now, multiply by the inside function, which is x squared, so that is 2x and minus 1. So that's basically it. So now let's move on. Alright, so we have this one over here. So for this type of question, you can basically perform them in 2 ways. You could either use a quotient rule to solve them, okay, so quotient rule, because they're dividing. But if you want, you can basically use a product rule to solve them as well. So how can we use product rule? Because product rule is multiplying with each other, right? So like I explained you guys before, right? So if you have like something to the power of in the denominator, this is simply equivalent to x to the power of negative 3, right? So that is basically what you're gonna apply over here. So 3t negative 1 to the power of 4 times 2t plus 1 to the power of negative 3. So these expression, they are basically equal to each other. So if you want now, you can basically go ahead and apply product rule because these two are multiplying each other. But if you guys want to use quotient rule over here, because these two are dividing, so you can use that as well. They basically end up gonna give you the same answer. So whichever works for you, you can basically go ahead and do this. Alright, so now let's go ahead and derive this expression right over here. So we have our f as this expression over here, and we have g as this one over here. So if we take the f prime, so we get 4 3t minus 1 3, and if we do g prime, so that becomes negative 3 2t plus 1 negative 4, and then derivative of the inside function, which is basically going to be 2, and here as well the derivative of the inside function, which is going to be 3. Okay, so if you do this, so that becomes 12 3t minus 1 3 okay, and this is your f prime, and your g prime is basically gonna be negative 6 2t plus 1 to the power of negative 4. Okay, so now simply plugging into the formula, f prime times g plus g prime times an f. Okay, so f prime we have is 12 3t negative 1t. Okay, and then we have g prime as, that is our f prime, sorry, f prime times a g which had 2t plus 1 to the power of negative 3 plus g prime, okay, times an f. So this basically completes your answer. But if you guys want to write it simplified form, let me just show you guys. So you can basically go ahead and simplify it. So if you do that, so this basically should end up giving you 6 3t minus 1 to the power of 3, and then 2t plus 1 negative 4, and then t plus 3. Alright, so this is basically the expression that you should get after factoring if you want to, but usually in the exam they do not ask for this, so they only want the expression itself. Because like if you have, like, for example, quotient rule, so that's going to be an ugly expression and it would be really hard to solve it, so usually they don't want you to factor anyway. So yeah, that answer should be good. I have this expression right over here, and here, like I said, the square root of x simply means x to the power of 1 over half, right? So now let's go ahead and write it in terms of power. So you have power on both of them, so we're gonna write a big expression like this. Okay, so now this is basically a chain rule as well, because you have u to the power of 1 over half, and this is basically your outer function, u to the power of half, and this right here that you see over here, x over x plus 1, this is basically your inside function. Alright, so now let's move on to this one and take the derivative of this one, so that becomes half x over half plus 1, and now we're gonna go ahead and take the derivative of the inside function. Alright, so that you don't know, how do you find the derivative of the inside function? So to take the derivative of inside function, if it was really simple like 2x plus 1, so that would be really simple to take the derivative of the inside function. But this inside expression that you see over here is basically a quotient rule right over here. Okay, and how do you find for quotient rule? That is basically f prime times g plus g prime times f. So you're basically going to multiply by the quotient rule, because you have to multiply, it's a chain rule, you have to multiply by the inside function, but the inside function is a quotient rule, so you're gonna go ahead and take the derivative of this expression by taking the quotient rule. Okay, so now f prime times g, and we have negative g prime times f over g squared. Okay, so f we have it as x, g we have it as x plus 1, f prime that's a 1, g prime that's a 1 as well. Now we're just gonna have to multiply, so f prime times a g negative g prime times an f over g squared. Okay, now if you go ahead and factor this, like if you just want to multiply, okay, so then basically it's gonna give you x plus 1, and you have negative x, and then you have x plus 1 squared, and x and negative x, they're gonna cancel each other out, so you'll basically left with 1 over x plus 1 squared. Okay, so you have this expression right over here for the quotient rule. So now you just simply have to multiply by this one, x plus 1 to the squared, and this basically completes your final answer, and this is just gonna be your final answer because you just take the chain rule. Okay, so that bring this down half and just write this as it is, and now multiply by the derivative of this expression, and this expression is basically coming from this, the derivative as it is. Alright, so now let's move on, and now we have to take the derivative of this expression, and you guys see this is a constant to the variable of something. Okay, every time you have a constant to the variable of something and you have to find the derivative of this one, okay, you have to find d dx of, let's say, bx. So d dx simply means take the derivative. Okay, so you have to find the derivative of b to the power of x, and b is a constant right over here, and x is a variable, right? And you have to take the derivative of this one, so that simply be equals to b to the x ln b. Okay, so that is something you guys have to know it by heart. Okay, so every time you see a constant to the variable of something, you have to use this right over here, the derivative. Okay, so this is something you guys have to know, like just memorize it. Okay, Okay, so now once you do this, you simply have to take the derivative of this one just like this, but you have a chain rule here as well. Okay, so here you have t to the power of 3. Okay, so if you have the t to the power of 3, you have to multiply by the derivative of the inside function as well. And what's the derivative of t to the power of 3? That's basically 3t squared, right? Simple as it is. Just like if we had x to the power of 3, so that is basically 3x squared, right? So just like that we have to do this. So now let's go ahead and take the derivative of outer function. So the outer function, we're just gonna follow this rule that you have right over here. Just we have x, we have like this. Okay. So you'll have b to the power of t to the 3x, and then you have ln of b. Okay, b is basically your 2 right over there. So that is basically the thing that you have to write. And now let's go ahead and multiply by the derivative of the inside function. So the inside function is, you see, over 3t squared. So that is basically it that you have to do. Okay, and this basically completes your answer, and this is your derivative. And if you guys want to write it in a simpler way, and if you guys want to write it a proper way, so that should be like 3 ln of 2t squared to 3 to the power of t to the power of 3. Okay, so that should be it. Okay, because here I made like constant before, and then you have t squared, and then afterwards t to the power of 3. Okay, just like if we write x squared, x squared, x cubed. So just like, you know, a better way of writing it, but they're basically the same thing. Alright, so now let's move on and take the derivative of this expression right over here. So here you guys can see, here you have your outer function as sine of something. Okay, so this is sine of something is basically your outer function, and this right here that you see inside the sine, this is basically your inner function over here. Okay, so that is basically a chain rule that you have over here. So that's to use a double chain rule over here. Okay, so that basically means let's go ahead and take the derivative of the outer function as it is while keeping the inside function as it is. Okay, so derivative of sine is basically cosine. So now we're keeping the inside function as it is, right? Just taking the derivative of the outer expression, and afterwards what you have to do, you have to multiply by the derivative of the inside function, right? So let's go ahead and multiply by the derivative of the inside function that you see over here. So the derivative of the inside function is a chain rule itself. Okay, so cosine of tan of x. So let's just take it as a separate derivative. If you had only this derivative given to you, how would you go ahead and take the derivative of this one? Okay, so you would go ahead and say, okay, so this is your outer expression right over here, and this is my inner expression. So what I'm gonna do, I'm just gonna take the derivative of the outer expression that I have. So outer expression is basically sine of something. So the derivative of the outer expression basically cosine of something. So that means the derivative of the outer, so cosine of something, that is gonna be negative sine. Okay, so negative sine of something, that is basically gonna stay the same. And afterwards what you're gonna do is like you're gonna multiply by the derivative of this inside function that you see over here, right? So now let's go ahead and multiply by this inside function. So the derivative of tan x is basically secant squared of x, and you just have to memorize this. Okay, so now once you have the derivative of this one, if only this expression was given to you, you're able to get to this thing. Okay, so that's what basically I have to do. So now you just have to multiply by the derivative of this inside expression that you have. So now you have an answer for this one that we just found over here. So that is basically negative sine of tan x secant squared of x, and this basically completes your final answer for this one. You have just finished solving this one. That it was as simple as this. Do not try to complicate your life. Let's go ahead and solve this question over here that we have. Okay, so if we go ahead and try to solve the question this that we have over here, so this one you can basically write it like, you know, if you have like sine squared of something, like I said, you can go ahead and do it like this. So you guys can see basically that it's a chain rule. You have like u to the power of something. So that is basically what you have to do. So you just have to write it in another form. So you have your cotan sine theta, and now you have to square it. So now you can you're able to see that this is like a chain rule. So now this is really simple. For the chain rule, what you do, you simply go ahead and take the derivative of the outer function, which is u to the power of something, right? So this is basically it, while keeping the inside function as it is. That is going to be once you don't have to write it, right? So this was simply like u to the power of 2. So you simply bring the 2 down, and that's it. Now you have to like multiply by the derivative of this u. So like this inside function that you see over here. So now we have to multiply by the derivative of the inside function. And this inside function that you see right over here, let's go ahead and take the derivative of this individually. So if I give you only the derivative of this one, because this is a question of double chain rule again. So now if I give you the derivative of only this one, so how you would go ahead and solve this? So you say, okay, I have this outer function as cotan of u, and this is basically my inside function inside the cotan. Okay, so the cotan is basically the outer function that I have. So the derivative of this outer function, this cotan only, what is the derivative of this outer function? So the derivative of the cotan is basically negative cosecant squared of x. Okay, so negative cosecant squared, so that's basically something that you have to memorize as well. Okay, so the cotan, and I have made video on derivatives, and I've already explained like some few tricks that you guys have to know to take the derivatives. Okay, so if you guys haven't checked those video out, and if you guys haven't checked the playlist of calculus, make sure to check it out, because I have given a lot of tricks on like how to memorize and know all these derivatives by heart. Okay, so make sure to check this video. I'll put the link to that in the I button. Okay, so yeah, so now let's continue with this one. So we have is negative cosecant squared for this one, and the inside function for now it's gonna stay the same, right? So you have sine theta. So now what you have to do is basically multiply by the derivative of this inside function, right? So now what is the derivative of the sine of theta? So sine of theta is basically cosine theta. So now you have your right expression over here for this one as the derivative of this expression right over here, and you wanted to take the derivative of this expression and then multiply by this, right? And now you just found the derivative of this expression. So now you just have to put this expression right over here in front of this expression, and this is basically going to complete your derivative. So that's it. So you have negative cosecant squared of x. Okay, so sine theta cosine theta, and this basically completes your question right over here, and this is your derivative, as simple as this. Okay, so now let's go ahead and find the derivative of this one, and this is basically product rule. You have your f, you have your g, and that's pretty simple. Okay, I just solved it for you guys. So here I have the f, here I have the g. Okay, so I have to just take the f prime of this one, I took it as this one, and g prime as this one, and if you do that product rule, f prime g plus g prime times f, this is what it should give you. Okay, but there's a catch to this one. So you know what, I intentionally did a mistake over here, and I want you guys to figure out what is the mistake in this question, and let me know in the comments below. Okay, let's see how many of you guys are actually paying attention. So I intentionally did something wrong over here, and please do let me know what is wrong in this question, in this answer over here. Alright, so let's move on. So let's move on to the last question of this video that we are making. Basically the last question that we have of this video, and since this is the last question, I want to ask you guys that if you guys want to give me any feedback on how do I teach, like did I do anything wrong in here, like or how can I improve here, if there's anything I did good or bad, like any kind of feedback, I would love to know them in the comment section below. So please give me some feedback so I could improve my content. And also, like, if this videos have been helpful to you guys, so please make sure to subscribe, because it motivates me to make more such videos. And also please do check out the playlist for Cal 1. I've already made a whole playlist on that. So now let's continue with this one. So for this one, we're asking to find the last and second derivative of e to the power of ex. Okay, so for this one, what you have to do, since they're asking for the second derivative, okay, so what you're gonna do, like, first you're gonna take the derivative of first one, then second one, and if the pattern is not visible to you, then you're gonna maybe like take 4 derivatives and see the pattern itself, and once you figure out the pattern, then it's really easy, right? So now let's go ahead and take the first derivative. So let's say that you have some function given to you like y equals to e to the x. So what's the first derivative of this one? Okay, so this is basically like a chain rule, right? So if you have e to the 2x, the derivative of this is e to the 2x and then times the inside function, which is 2x, right? So that is basically 2. So this should be it for e to the 2x. So this is basically the same thing. You have your derivative as this one, so you're going to write the exact same thing, e to the ex, but now you have to multiply by this inside function. Okay, so this inside function, so this e is treated as a constant, just like 2x, so the derivative of 2 is basically 2, 2x is basically 2, so the e to the x is basically e. Okay, so you get your e to the ex as the first derivative. So that is the first derivative. So now if you go ahead and take the derivative again, so f prime prime. Now this is your second derivative. So second derivative. So now you have this one, and you have to take the derivative of this one, because you have to take the second derivative of this one. Alright, so now you have this one. So here, because this one is like 2e to the 2x, okay, so this is basically like a constant, so you only take the derivative of this expression right over here, and the constant is just gonna go outside the derivative, okay. So the constant, it doesn't matter, it's just gonna stay over there as it is, okay. So the constant in this case is basically e, okay, so that is just gonna stay over there, and then you have to multiply by like the constant is just gonna stay over there, and then you have to take the derivative of this expression right over here, e to the ex, okay. So e to the ex, like we said, it's exactly the same thing, but you just have to multiply by the derivative of the inside function, which is e, okay. So now if you multiply this, like that's e to the ex, okay, e times e, so that's e squared e to the ex, okay. So you get this one as your second derivative. Now let's go ahead and take the third derivative, okay. So let's go ahead and take the third derivative. If we take this, so now we have to take this expression and take the derivative of this one, and this, like I said, this is basically a constant, so it's just gonna stay over there just like that, okay. Now we have to take the derivative of this expression that you guys see over here, okay, this expression. So now the e to the ex, just like that, stays over there, and then multiply by the ex, this inside function that you see over here, okay. So now if you do this, that inside function that you see, okay, so that is basically e, right. So now this becomes e to the e squared e times e to the ex, which is basically equals to e to the power of 3ex, okay. So you guys are trying to see the pattern over here that we are getting, okay. So for one, okay, so I'm just going to change colors, let's say green, okay, so make it darker, okay. So now for this one, for the first one, we got e to the ex. For second, we get e squared ex. For third one, we're getting e cubed ex. So fourth one, what should you get? For e to the power 4ex. For the 5, what should you get? e5 e to the ex. So you guys are starting to see the pattern. So whatever derivative that you're taking, that is basically gonna be your exponent right over here, okay. So that's as simple as this one. So basically what you are going to do is, like, because the second derivative they were asking for you, so that is basically done. They're asking the last derivative, and by the last derivative they simply mean like an expression to write this derivative, because there's no, like, this function cannot end, right. So like there won't be any last derivative. So here the catch is basically to write this as an n function. So e to the power of, if you have to take the derivative of y of n, so that would simply be equals to e to the power of n e to the power of ex, and that's basically it, what you have to write for your answer, as this one and as this one. And this basically completes the video. I hope you guys enjoyed watching the video, and thanks for watching.